Welcome to Plumbing Level 2. Today, we are diving into rainwater sizing, specifically focusing on the guidelines laid out in the 2015 National Plumbing Code of Canada. We'll learn how to calculate hydraulic loads for roofs and size our drainage systems properly. When we size rainwater liters, we calculate all loads in liters per 15 minutes. To find the hydraulic load draining into a liter, you simply measure the roof area in square liters and multiply it by the local rainfall data. Just remember, 1 liter of water spread over 1 square meter equals exactly 1 millimeter of depth. Let's look at an example. Suppose our local rainfall data, which you can find in the National Building Code, is 10 millimeters per 15 minutes. If we have a roof that is 10 meters by 18 meters, our area is 180 square meters. Multiply that by 10, and we get 1,800 liters per 15 minutes. Once we know our hydraulic load is 1,800 liters, we consult Table 2.4.10.11 for the maximum permitted hydraulic load drained to a liter. Looking at the circular liter column, a 2-inch pipe only handles 1,520 liters, so we must step up to a 2.5-inch liter, which handles up to 2,770 liters. Now, what happens when we combine storm and sanitary drainage? For a combined building drain, our first step is to calculate the load from standard sanitary fixtures. We add up the fixture units, excluding any continuous flow fixtures, and convert them to liters per 15 minutes. In our example, 250 fixture units convert to 2,360 liters. Step 2 involves our continuous or semi-continuous flow fixtures, like sump pumps or clear water waste. Because our baseline is 15 minutes and there are 900 seconds in 15 minutes, we simply multiply the flow rate in liters per second by 900. Half a liter per second becomes 450 liters per 15 minutes. Finally, we add all 3 loads together to size the combined building drain. We take our 1,800 liters from the roof liter, 2,360 liters from the sanitary fixtures, and 450 liters from the continuous flow. This gives us a total hydraulic load of 4,610 liters, which requires a 4-inch pipe at a 1 in 50 grade. When you look at a full building schematic, the process is the same but requires careful tracking. You'll need to note the local rainfall data, which is 12 millimeters here, the drain grade of 1 to 50, and whether stacks are multi-story. You evaluate each branch, stack, and liter individually before combining them. Let's size a specific liter from the sample drawing. We have a roof section that is 20 meters by 20 meters, giving us an area of 400 square meters. Multiplying that by our 12 millimeter rainfall data yields 4,800 liters per 15 minutes. Checking our sizing tables, this requires a 3-inch liter. Now, let's calculate the load for combined drain number 6 on that drawing. We pull down the 4,800 liters from our roof liter. Next, we convert the 100 sanitary fixture units, which gives us 2,360 liters. Finally, the half liter per second continuous flow adds 450 liters. Our total load for this section is 7,610 liters. That wraps up our module on rainwater sizing. Remember the golden rules. Always work in liters per 15 minutes. Calculate your roof load by multiplying area by rainfall, and systematically add your liter, sanitary, and continuous flow loads for combined drains. Keep your units straight, and you'll size these systems perfectly every time.